As the gentleman just pointed out, my name is Charlie Brown. I work for Maryland State Highway Administration through a contract through GPI. I'm on the AASHTO committee for the domestic scan, for bridge preservation, practices for steel bridge coatings. And the participants, as you can see, were from all over the United States. We had them from Maryland, Washington, D.C., Oregon, Texas, Florida, Kentucky, and Iowa. We had participants in our desk scan that came from the West, Midwest, Northeast, South. Basically, what we were trying to talk about is how to protect our steel bridges, our steel structures. Just some background information. Some of you might have seen this before, but the cost of corrosion in the United States for transportation-related corrosion in the U.S. runs about $276 billion in 1998. The cost on corrosion in the transportation bridge industry is about $30 billion. So it's a big number. It's something that all DOTs have to deal with. It's something that we in this room have to deal with all the time when it comes to preservation and bridge preservation in general. When we sat down for this scan, we had to get a scope. We all met in DC preliminary to sit down and discuss what we wanted to try and get out of the scan. Basically part of it was to determine the amount of funding that the agencies could get, evaluate the practices we use for bridges, for in-situation coatings, what type of surface preparation are we going to be doing, or what we're going to be recommending, coating option decision-making, use of performance-based contracts, performance evaluation and overcoat and replacement of coatings. So we went on and on and on about what we were going to do in this domestic scan, and these are the areas we covered. You know, in other areas were quality assurance, quality control, contractor qualifications, and agency commitment to supporting future preservation of coatings. When we talk about bridge preservation, the definition is extending a bridge's service life by doing the right thing at the right time. So a lot of situations you run into where you're going to have a bridge, it might be 15 years or 20 years out before you do a redeck. It could be, 30, 40, 50 years out before you're doing any major maintenance, but we have a corrosion issue. So what are we going to do to maintain that structure? And so part of the scan was to determine what the best practices are. So when we talk about paint or coatings, in the Federal Highway Bridge Preservation Guide, it's listed as a preventive maintenance action, along with like debris cleaning and bridge washing, et cetera. But due to the cost and repairability, paint was considered a bridge element. So when we sat down with all these folks at this meeting, we had 11 state highway agencies have preventive maintenance programs. 6 owners have steel bridge preservation programs, and they use life cycle costs for effective coating decisions. The other issue was the dedicated funding for bridge painting. How is it done? Do they have a set program? Do they have a set amount of money? Do you just put out money when you need to? So when we talked about dedicated funding, the whole idea is to have an effective program, you need to have a dedicated funding. We talked about inventory and structure condition and other specific attributes. When we started talking about evaluation practices, a lot of DOTs did different types of evaluations of the coatings in the field. But mostly they all followed and did assessments making maintenance painting decisions by the NBIS. So it was done under 2-year biannually in-service bridge safety inspections, and coating assessment tools that they would use are like the SSPC Viz guides, custom photographs, tensile adhesion testers, took gauge, thickness gauges. So there are a lot of different things in the arsenal that they use to evaluate bridge practice for the coatings that are out in the field. I also use the element level bridge inspection for coatings. Virginia had its own developed elemental standards, and Oregon developed an elemental standard for themselves. And then Iowa had a microenvironment to identify local areas of a bridge. For the most part, when we talk about coatings and structural steel, for specifically bridges, when you look at a situation like corrosion what is the best method for cleaning the structural steel and making sure it's set up and ready to be having a coating applied to it. Most of the state highways specified SP10, which is a total removal, blast clean to a near white. Surface preparation varied a lot for spot cleaning and painting. In that situation, though, you could use hand tool, power tool cleaning, all the way up to spot abrasive blast cleaning. Most of the SHAs utilize the SSPC Guide 6 for containment. It's a very handy guide for all the DOTs to use in regards to the containment systems you want to use to collect the waste during abrasive blasting or hand tool, power tool cleaning. The other thing that was noted that was real interesting is a lot of state highways are moving away from overcoating work. When you start talking about overcoating work and overcoating an existing coating, a lot of them are getting away from it because the sheer cost of putting up containments for structures to do overcoat work, that's over half the price of what the job costs. So they're finding out that if we do a complete blast or complete removal and a paint versus an overcoat, they're not talking about a big difference in price. So a lot of DOTs are getting away from overcoating work. California State Highway is a little bit different than most state highways I've ever talked with because they have their own in-house painting crews. Okay, so does the Golden Gate Bridge. They have their own painting crew as well, and they both gave presentations. And it was interesting to hear how they go about it. But they do some overcoating because they want to extend the life of the lead coating that was applied many, many years ago. Because if some of you don't understand that lead is the best corrosion inhibitor out there, the next best would be zinc coating. And so instead of removing all the lead, they want to try and keep it on. I thought that was quite interesting. Oregon, which uses an ultra-high pressure wash to remove pack rust. Specifically, they use this process to remove pack rust between plates. You have, especially when you're built up members, when you're bridges that have truss connections, where you get a lot of heavy pack rust and you start getting the steel starting to pull apart, they use high pressure water to remove all that pack rust, and then they go in and coat it to keep it from having any further delamination. Texas was using water blasting before any mechanical surface preparation was done. They had some success with it. And New York uses hot pressure washing to remove surface contaminants. So during the domestic scan, we talked about coating options and decision making. And everybody in this room has the decisions to make when it comes to their structural coatings and what they're going to want to do for how you're going to protect the steel and how we're going to get the work done and also how we're going to pay for it. Total removal and replacement was seen to be the best. It gave us the most longevity, anywhere from 15 to 30 years, depending on the structure and the location of the structure. For overcoat, we were looking at somewhere between 10 and 20 years. We were also looking at high performance coatings and systems that are out there. We have a lack of historical data on these high performance coating systems. There's a lot of new coatings coming out on the market. There's the high build polyurethanes. There's all different types of coatings coming out, and then people are touting them as the best. And this is the next best thing to use on your bridge. It'll last for 20, 30 years. The problem with that is we have no historical data on any of those. And so it's a kind of like a wait and see type situation. Most folks out there have seen and used your 3-coat zinc epoxy urethane coatings for 30, 40, 50 years, and they have a longevity and a track record. And so a lot of people have decided that that's the way we're going to go. And then we talk about testing high performance ultra-wearable coatings. We're talking about using a modified weathering, accelerated weathering testing, outdoor exposure, and different top coat colors. And that was one thing that was brought up at the domestic scan is about top coat colors and fading. And they want to try and get better top coat colors and products that will last and provide the sheen instead of starting to fade over time. And one of the other things was discussed was metallizing. New York and Ohio had done some metallizing work that's something out on the horizon that could be of interest to certain locations for certain DOTs, but metallizing is very expensive. When you talk about total removal for an average overpass bridge, you're looking at anywhere from $12 to $15 a square foot, depending on the location. New York, it's probably more like $40 to $50 a square foot. But when you start looking at metallizing, you're looking at average areas $40 to $50 to $60 a square foot, depending on the location and the size of the structure for metallizing. During our talk at the domestic scan, we talked about use of performance-based contracts, specifically warranties. As I was introduced, I work for Maryland State Highway Administration. We use warranties. We find that it works very well in regards to making sure a contractor does a job right. When we discussed this in the domestic scan, Maryland and Michigan, we use 2-year condition performance warranties. Oregon uses a 3-year. The Golden Gate Bridge District has a 5-year on contractor work for labor and materials. When it comes to the 2-year warranty, we require a separate bond. In Maryland, we require a separate bond for the warranties. And that bonding is to make sure that the contractor's work and performance that he did lives up to the expectations of what we paid for. So we require a 25% total amount bond for the work that they've just done. Oregon, on the other end, requires 90%. Both of them are requiring, for warranty work, any type of surface preparation, platform containment, any type of pack rust removal. It has to have some type of performance guide to give to the contractor what we're requiring them to do. Then inspection and frequency enforcement language in a spec. Of course, everybody has their own specifications, but when you talk about coatings and you're talking about the work that's going to be done out there by a contractor, you have to make sure that you have language in there that you can hold them to. It's really important to make sure that the language you put into the contract has enough teeth so that you can get done what you want to get done and get it done properly. And then a lot of the SHAs are using AASHTO's NEPPEP and NEPCO program for their coatings. Some of the SHAs perform in-house testing of coatings. They test the chemical compounds and characteristics. And then Texas and California actually have in-house formulations of their own coatings that they specify out on bridges. When we talk about specifications for coatings, there's a long list here. I'm not going to go into every single one of them. You've probably all seen them before. The whole idea here is when you have a specification, you need to make sure that you touch on all the points that are going to be required for your specific job. Now, most bridge work is bridge work, so you can get a boilerplate spec and put it out there, but you need to also address the areas which are going to be different. And those areas need to be addressed in the specification as either a special provisions or special provisions insert into a standard specification. But remember, when you're doing your specifications, make sure that you get everything that you need to get into that spec. We require in Maryland, just for instance, all contractors to be SSPC QP1 and QP2 certified. We have that into our spec. Some state agencies don't have that. Again, it all goes back to the situations that you've run into in the past. We've found that specifying QP1 and QP2 really works. That's for us. Some of you might find something else. But the biggest things here is making sure that you have your material specs, what kind of containment you want, qualifications for the contractors, any consultants that might be on the job site, you know, your record keeping requirements, hold point inspections, you know, stripe coating. Stripe coating is a real big issue in certain areas. We require stripe coating. I was just talking with somebody earlier where a DOT is requiring stripe coating on every coat, and then within 5 feet of the beam ends, they're asking for another full coat of another coat of epoxy. So everybody's a little bit different for their needs. So just make sure whatever your needs are, you put them into your spec. Also, you need to worry about safety, waste designation and removal, because a lot of the material coming off these bridges probably contains lead, or some of them contain lead. Any traffic control requirements, and some might be included in your bridge plans. The next thing I'd like to talk about is quality assurance coding inspection requirements. Very important. How do we make sure we get the job done that we want? We found out at a domestic scan that this is one of the main issues, other than the specifications and material selection, that the DOTs have a lot of control over, and it's the coding inspection. For instance here, one SHA had an in-house personnel perform all QA inspections. Well, that's great, but a lot of DOTs don't have that kind of funding and that kind of money to have in-house people doing that kind of work, especially if you got 5, 6, 7, 8 different jobs going on out there on the street. 5 different state highway administrations had consultants for QA inspections, and 6 of them, had a mix of in-house and consultant for QA inspections. When it comes to QA inspection, the most important part is making sure that the inspectors you have, whether they're in-house or whether they're consultants, have the correct training, education, and experience to perform these inspections. Because again, this is the person that's out in the field that's going to be making sure you're getting what you're paying for. So in this situation, we came up with a minimum qualification of at least an ACIP level 1 or an SSPC BCI level 1. And some state highways specified even higher. I know Virginia requires, I do believe, a NACE level 2 or a BCI certified. And then requirements for in-house personnel varied. But again, I can't stress this enough. Having the correct personnel, the correct trained, educated, and experienced inspector, person out on the job site, is really important. On the QC training, for the contractor qualifications, that's another thing. You know, when you talk about SSPC and QP1 and QP2, which I'm very, very familiar with, I used to be a painting contractor for 14 years. I was a chairman of the SSPC's program, painting contractor certification program. We dealt with these contractor qualification issues. Having a contractor out on the job site and having his personnel having the right qualifications to do the job right is really important. We also agreed in a domestic scan that having that there and making sure that the contractor's personnel were qualified. Maryland actually has it in its specification, and it's something I would recommend to all DOTs to have in their specification. The QC inspection training for the contractor's personnel is paramount. All state highways that were there required some kind of training before assigned to a project. Training of in-house and personnel was on the job. And industry-based training was okay to a lesser extent. And then there was in-house instructor-led training, which was also good. The whole idea here is to make sure that the contractor's personnel have been trained, because they're the ones that are going to be finding the things that they're supposed to find. QA inspection is QA, it's quality assurance. We're not out there to do the inspection for the contractor. And then when we talked about contractor qualifications, 9 different state highways require QP1 and QP2. 3 of them require QP3, which is blast cleaning in the shop or cleaning and painting in the shop. 1 SHA did not need any QP certification, and 1 SHA allowed QP7 for new contractors. Agency commitment to supporting future preservation of coatings. Asset management. I'm going to be speaking of these. All of you folks have your own niche of what you do at work. But when we talk about the commitment, we talk about what kind of dedicated group and personnel you have for coatings for your DOT. What is your overall maintenance budget and on a system level for coatings for your structures out there? And then you have your bridge management system, your PANAS, what are your network level trends, and what are your bridge needs based on the system-wide constraints that you are involved with. And then bridge maintenance management systems, your project level needs, and establishing performance measures for maintenance painting. State Highway has a program that we use that I'll be talking about later on. But here comes the meat of what we did at the domestic scan and our recommendations. We have a report that's going to be coming out probably in approximately, I'm going to say at least 2 months. the summary report right now is being reviewed as we speak. So hopefully the final report will be out in a few months. But some of the recommendations we had from the SCAN team are dedicated bridge painting funds. You guys in the DOT world need to dedicate funds for coatings. If you don't already do it, you need to do it. Evaluation practices for in-situ coatings prior to recoating. You need to have some type of inspection elements. And you also need to have maybe your own agency developed elements for your own purposes for inspection of coatings. When we talked about surface preparation, there was ultra-high pressure washing to remove pack rust. We found that on specifically like truss-style bridges and built-up member bridges, when you have pack rust that is going in between the steel members and it's starting to pop those steel plates, the only way to really fix it is to do a high-pressure wash to remove that pack rust and then to coat it. A crevice sealer for the inhibit the corrosion in those areas as well. The laser coating was something that was brought up at the end that might be something in the future, probably way in the future. And then coating option decision making. We talked about duplex systems and painting over hot dip galvanized. That's something personally I'm not a big fan of, but in certain situations when you want to have a color and you need to paint over high dip galvanized, there are systems out there that you can do that with. Ultra weathable coatings, that's another thing that people are looking into. But when we come to recommendations, the other thing was using performance-based contracts. We've come to find out at Maryland the use of a 2-year warranty doesn't really increase the price all that much. Actually, it doesn't really increase the price at all. 2 years, if a contractor does the job right, it should look good in 2 years. We shouldn't have any problems. But with a performance-based warranty, having that warranty in place, if the contractor didn't do his job properly and we didn't catch it, when we do our 2-year warranty inspection, we'll find it. And he'll be required to come out and fix it. And we have a mechanism to go ahead and have him do that, because if he doesn't come out and fix it, we have a bond we can go back and get the money to have another contractor perform the warranty work. Which, in my 8 years at State Highway and then 14 years as a bridge painting contractor, I don't know if State Highway ever having a situation where they didn't have a contractor come back and do the warranty work that was required. And then your performance evaluation of overcoat and replacement coatings. Excuse me. Incorporate colorimetry into testing protocols, modify national trends. When we talked about overcoating, I was talking to a gentleman outside. In our domestic scan meetings as well, it's come to find out that most overcoating work is not being done anymore, or it's being done on a limited basis. When you talk about installing containments and whatnot, it gets very expensive. And we've seen the same thing at Maryland, where we're paying almost the same amount of money to have a bridge overcoated versus completely cleaned and painted. So we don't really do any more overcoat work. Specifications for coating systems. If you're doing a total removement, do it at a minimum of SP10 near white blast clean, or better. If you're doing weathering steel, paint the beam ends, a minimum. Blast clean and paint the beam ends. I recommend doing the fascias as well. Right now at Maryland State Highway Administration, we're working on a program on our weathering steel bridges to determine whether we should just completely clean and paint them instead of just doing the zone type blast cleaning and painting. Of course, we're all in the Northeast, so we all have the same problems when it comes to salt, weather, winter weather, freeze thaw. So, I mean, everybody's a little bit different, but we're looking at doing something a little bit different on our weathering steel bridges. When you're talking about specifications, incorporate hold points into your specification for inspection. Specify full-time inspection. I've seen it working in Virginia, Delaware, Maryland, Pennsylvania as a contractor. I've had all different kinds of inspection from paint inspectors, from full-time inspection to hold point inspection. And I will say one thing, you will get the most bang for your buck with full-time inspection. Stripe coating, very, very important. The committee said that was one of the priorities, is to make sure that we put stripe coating in here. And then bridge washing to remove surface contaminants. There are a lot of restrictions many, many years ago, Maryland State Highway Administration used to pressure wash all its bridges as part of its maintenance program. And part of that process was to remove surface contaminants. Well, it's very difficult to do that in the days now in regards to environmental concerns because of the issue with our environmental department in Maryland. You know, you have salts, oils, grease, and you know, we have the Chesapeake Bay, which is not that far away. So we no longer wash bridges anymore. Some states still do that. Whatever it might be, it's real important just to maintain your structures. And then quality control inspection qualifications and the contractor qualifications. Our recommendation is to specify at a minimum an ACIP and or SSPC BCI. And the recommendation was also to recommend that all your contractors are QP1 and QP2 certified. The agency commitment to supporting future preservation of coatings. Tracking the information is like paramount. You painted a bridge over here today, you need to keep track of that information down the road 10, 15, 20 years from now. Communication with different SHA organizations. Networking. So with these program that you're here today and this past couple of days, is talking to each other and finding out what works for you and what doesn't work for you and trying to glean other information from other folks. That's what these programs are about, especially having this type of conference. And then we had one person in Virginia who let us know that they are trying to reduce or eliminate all joints on bridges. It sounds kind of far-fetched, but they're working on a process to try and eliminate the joints because, of course, you all know that where's our heaviest corrosion located at? Most of it's located at our bearing and beam ends where they're joint locations. And waste disposal, specify as hazardous. Even if you're cleaning and painting a bridge that had a zinc coating on it, it's just easier to dispose of material that way it's hazardous. You have to remember as a DOT that you have responsibility for any waste that you generate, cradle to grave. Okay? That means you own it from when the time it comes off the bridge till it goes in the landfill, and while it's in the landfill, you still own it. So it's better just to specify it as hazardous. And then these are just some of the team members that were on these are the team members that were on the domestic scan. We had Paul, who was our chair from Florida, and myself. Ray was from Oregon, and we had Justin from Federal Highway, Tom from Texas, and Mike from Iowa. And then we had 12 different workshop participants, which were owners throughout the United States. So I don't know how much time I have left. But any questions on that part before I go into the next one?
I'm confused when you said that, I mean, the right thing to do is to dispose of the zinc as hazardous waste because it is hazardous. The environmental rules state no heavy metals and deleterious materials. So zinc is as hazardous as lead in relation to the environmental rules. And in Europe, they're doing research now. They're finding it's almost as hazardous to people's health as lead is. So that's a very good recommendation to handle it as a hazardous waste because it is one.
Well, what a lot of DOTs and a lot of contractors are doing T-clip analysis to determine whether the waste stream that they're generating from is hazardous. And then some of them are coming back non-hazardous, even though it was a zinc product. So, well, what we decided was in the domestic scan was that you should classify all the waste coming off these steel structures from cleaning and painting as hazardous. Thank you. Any other questions? No other questions then? Thank you.